as an independent consultant with governments and NGOs around the world, with many countries, in the regulatory framework for energy efficient lighting. Thanks, Maxine.
Great, thank you so much, Steve. It's also great to have you here. Thank you. And finally, Michael, I would like to invite you to introduce yourself.
Hi, good morning, good afternoon, good evening. Excuse me. My name is Michael Bender, and I direct a small nonprofit here in the US called the Mercury Policy Project. I'm also the international co-coordinator of the Zero Mercury Working Group, which is an international NGO coalition of over 110 organizations from more than 50 countries. My background, even before starting to work on specifically on mercury issues in 1998, starting in 1992, I started a North American Hazardous Materials Management Association, which was comprised mainly of state and local government officials focused on reducing the toxicity of the municipal waste stream, and specifically looking at household hazardous waste and managing that, and what we call small business hazardous waste, or small quantity generator hazardous waste. Looking forward to the discussion. Thank you.
Great, thank you so much, Michael. Thanks for giving us your time. Okay, so I think we're going to head into our first bit of the presentation. So Eunice, if you could just take us to the next slide. And I'm going to hand over to Colin, who is going to start us off today. Thanks, Colin.
Thank you, Maxine. So as a just sort of general introduction, the Clean Lighting Coalition is a global partnership working to capture the health and environmental benefits of eliminating mercury-based lighting. And so our work sort of has as a centerpiece the Minamata Convention, which seeks to get rid of mercury in general. And when it was implemented, there were some exemptions for fluorescent lighting, which includes mercury, because there weren't necessarily widely available and cost-effective alternatives. And that's changed now with the advent of cost-effective LED lighting. And so what the Clean Lighting Coalition has been doing over the last few years is engaging government agencies with locally relevant evidence about the benefits of transitioning to clean lighting, to LED lighting, especially showing how LEDs are often even cheaper than fluorescent lighting in terms of upfront costs, and usually consume half as much energy or even less as compared with fluorescents. And through that engagement, we've been building a network of champions to promote consensus building around this transition to clean lighting. That consensus building led at the fourth conference of the parties of the Minamata Convention to a unanimous decision to phase out compact fluorescent lighting by 2025. In addition, there has been an amendment proposed by the African region to phase out remaining categories of fluorescent lighting by 2026. And so this engagement with governments and with different representatives around the world has led to a variety of, to some significant decisions phasing out this kind of toxic lighting. Beyond that, we've been working on activating advocates in the public, coordinating with public health and environmental advocates and consumer groups to advance national campaigns. And we've been building public awareness for accelerated action. And between those two things, working with governments and working with advocates, we've also been working with on implementing national policies that phase out fluorescent lighting and move to all clean LED, clean, efficient, high quality LED lighting. In addition, we also engage with the private sector, working with progressive lighting companies, component makers, distributors, and so forth, to pledge to only make LEDs and highlight the private sector benefits of transition. In many cases, fluorescent lighting is only manufactured in a few countries, whereas LED lamps and luminaires are assembled in many countries around the world. And so shifting to clean lighting actually brings economic benefits for most countries in terms of promoting local manufacturing over imported toxic products. So that's generally the Clean Lighting Coalition in a nutshell, and I will hand it over to Steve Coyne, I believe, for the next, for the first question intro.
Thanks, Colin. Okay, so our first topic here today is looking at the technical readiness and economic benefits of Mercury Free Lighting. And we'll just highlight the technological and economic opportunities that present themselves with that. So next slide, please. So really what we have in the last 10 years or so is we've had this disruptive technology come into the lighting marketplace and lighting industry called light emitting diodes. And whenever a disruptive technology comes into a market, there is a huge upheaval in that marketplace in terms of use, the business cases and opportunities for the application to change the way we use lighting. So with the proposal here to remove all of our mercury-based lighting, what we really need to consider is, can we transition away from all of those mercury-containing lamps? Are we technically ready? Are there economic benefits in doing so? And then also, has anyone done it already? So is there regulation already in place? So as Colin was just mentioning, on the right-hand side there, on the slide, we have what's occurring in the Minamata Convention through the various COP4 and then the upcoming COP5. There's been various stages of removal of compact fluorescent lamps initially from out of the marketplace that had fairly high levels of mercury in them. So they're the ones that are highlighted in white background on the tables there. We then have two in there that are highlighted in green, which were agreed to at COP4. And so the phasing out of those has occurred. And then we have the areas that are highlighted in the blue and the orange color are those that are being discussed at COP5. Some of those are new proposals, some of those are proposals that were carried over from COP4. So with the entire suite of proposals there, we've effectively got now on the table for COP5 a removal of all fluorescent lighting products from the marketplace. And just showing some examples of those in the middle there, the types of technology. So your compact fluorescent lamps, whether they be the integrated compact fluorescents or non-integrated, the circular forms, the linear forms, and even the induction lamps as well. So has anyone regulated yet? Well, yes, it has. Some of the regulation has come into place already. As you can see in the bottom left-hand corner, in December 2021, the European Union made an announcement that they were phasing out the mercury-based products. And in fact, in February this year, the compact fluorescent lamps and the circular fluorescent lamps were banned for sale in Europe. And then in just under 3 weeks' time in Europe, the linear fluorescent T8 and T5 fluorescent lamps will also be banned for sale. So this process of regulating or putting regulation in place, as you can appreciate, is not done lightly. All of the investigations are done in the background to determine whether there's potentially going to be, are we technically ready, and is there a cost benefit in doing so, as well as the health implications associated with removing the mercury. Next slide, please. So are we moving towards this? How are we moving towards this at the moment in terms of the transition? Well, approximately 20 to 25% of all of the installed linear fluorescent lamps in the world are replaced each year. And on the right-hand side there, we can see the exports from the major exporters of linear fluorescent lamps around the world. China being the main one, the orangey red line in the middle there, diminishing. And at the top there is the total exports from the top 10 exporting countries. And you can see for over the last 10 years, there has been a significant reduction there. More than half of the number of linear fluorescent lamps were exported 10 years ago, and now only been less than it has been exported today. So does that mean that they're not required anymore? Well, obviously not, because lighting is still required. So those linear fluorescent lamps are either being replaced with another lighting technology, as in the linear LED lamps, or they're being completely replaced with new luminaires. The lighting fixtures are being replaced with an LED type. So there's an increase, there is a growth or an increase in this replacement that's currently happening through the natural market progression and the transition to, as I said, this disruptive technology. And what are the benefits of that? Well, from a Mercury perspective, the products that are currently installed, the linear fluorescent lamps are installed today that are currently out there in lighting fixtures. Throughout the next 7 years or so, they will all fail, and there will be approximately 30 tons of mercury waste associated with that existing lamp technology fluorescent lamps that are installed. If we're able to put a ban in place by 2025 or 2026, we will then stop any further mercury-based products being installed, and we have the potential to stop another further 5 tons of mercury becoming waste throughout the 2030 and beyond. So there is some benefit and some opportunity in conducting this phase out. Next slide, please. The question always is, are these linear LED lamps able to replace the linear fluorescent lamps in these fixtures? And are they technologically compatible? And also, is it economically viable? Is there benefit in doing so? Well, as mentioned before by Colin, the LED lamps are twice as efficient. So therefore, they're effectively half the electricity consumption of your linear fluorescent lamps for the same amount of light. They last for 2.5 to 3 times longer than a linear fluorescent lamp. So therefore, the changeover costs, the labor costs associated with lamp replacement is effectively cut by 1/3, 2.5 to 1/3. So there's an economic benefit in changeover. And there has been an investigation conducted, analysis, and it looks like 91 to 94% of cases LED are able to retrofit the existing linear fluorescence in some of the fixtures that there are, and that has been promoted widely by the manufacturers of those products, making those claims. And we also have some safety standards in place that look at the safety of those products. And there is a new safety standard coming out that's even going to revise and improve and even get that to a more improved standard as well. The right-hand side here is just a classic graphic provided by one of the manufacturers showing the phase-out dates for particular lighting, fluorescent lighting products, and then indicating the alternatives they have in the form of a lamp, and then also in the form of a luminaire. So next slide, please. So where are some of the opportunities for countries? Whenever we have disruptive technologies, there is always going to present great opportunity. So there's a total of total LED lamp exports in last year was approximately 6.1 billion lamps, LED lamps, of which 90% of those were produced by China. The other 10% have been produced in approximately 30 countries. So very small amount of production in other countries besides China individually. Of that 6 billion produced by China, approximately 10% of those LED lamps are in the form of the linear LED lamps. The other 90% are in the form of your standard light bulb. So this actually presents an opportunity, these LED lamp products. So as you can see in the top right-hand corner there, we have a diagram, a schematic of a linear fluorescent lamp. And here we've got to have a good understanding to manufacture these products. We've got to have a good understanding of lamp physics. So we've got an understanding about gas pressures, about the voltage required between the two arcs at each end of the tube, and also about the physics associated with the phosphors that are in there for being able to convert the ultraviolet light into visible light. So it's quite a technical piece, and it's quite a lot of expertise is required to produce and manufacture these products. Whereas now you can see down the bottom there the array of three different schematics, or two schematics and a photograph, is that LED lighting is effectively just an LED chip, which is a semiconductor device which does take sophisticated manufacturing, but everything else about those lamps is rather unsophisticated effectively. It is just some diffusing components, and then it is just some electrical circuitry, no different to any other electronic products. So they would be readily able to be manufactured, assembled and manufactured in any country upon being able to import the LED chips into that country to be able to include into these products. And as you can see with the filament-based LED light bulb in the middle there, it is effectively an incandescent light bulb with a different filament structure in there for the LED instead of the tungsten filament. So there is great opportunity potentially in countries for the assembly and production of these locally. Next slide, please. So from that, we really bring you up to the question now, which is, which market sectors in your country do you think would benefit from the accelerated transition from mercury-containing lamps to LED lamps? And as we've started a bit of a song here, we're talking about turning off the mercury tap. So I invite you now to pose your questions and some comments, please, about which market sectors you think could benefit in your countries through this opportunity, economic opportunity.
Great.
Thanks, Maxine.
Thank you so much, Steve. Thanks for that. That was great. So yes, as Steve mentioned, the question has been posted in the chat. So please feel free to post your answers and ask any further questions that you have for our presenter. And we will discuss this question for the next couple of minutes. We will launch some polls in a few minutes. And so, yeah, go for it. We're excited to hear your thoughts. And Steve, you're more than welcome to leave your camera on and your microphone unmuted if you would like to respond verbally to anything in the chat. Just a note, if you are not sure where to find the chat, please just look at the bottom of your screen. There's a little speech bubble, and then it says chat underneath. You can click on that, and that is where we will all be discussing. And once again, if you have just joined us, welcome. Please remember to introduce yourself in the chat. Give us your name, the organization that you represent, and the country you are from.
There's some questions, some comments as we're going. There's first few comments there about the utility agencies or sectors and the energy sector. Yes, definitely agree with that. As we said, with them being twice as efficient, there is a reduction in the electricity requirements for lighting. In a lot of countries, the linear fluorescent lamps make up probably about 50% or more of the light points in countries, and the electricity consumption by lighting can vary between 8 and 40% of the electricity consumption in countries. So if we can remove all of the linear fluorescence, that will significantly improve some of the electricity security, if you like, for countries. Of course, removing the mercury from the environment is a key thing, particularly for our children, and making safe places. There's a couple of questions there. One question there for me in terms of, what are the challenges for developing countries in completely replacing linear lamps with LEDs? There are a few challenges in terms of just understanding the lighting products that are currently installed, and it may well be it's really understanding the ballasts, if you like, that are there with some of the linear fluorescent luminaires, particularly if they're very old ones. In those situations, the best solution is actually replacing the whole fixture. So rather than using a linear LED lamp, is going with an LED luminaire. And one of the most cost-effective and very simple ones to use these days is the LED panels. Are very cost-effective, and again, a great opportunity for countries in terms of assembly, local assembly. So I see those as being a great opportunity. And the challenge, as I said, is probably ascertaining what is the best option for installations, whether it's to just replace with an LED lamp, whether it is to replace the fixture completely. The other comment there in terms of reducing electricity consumption load, since we're facing load shedding, as a country, that's another opportunity. When it comes to linear fluorescent lamps, you find they're generally used in the commercial and industrial retail sectors. So that lighting is generally used during the daytime, when we have the highest loads in some countries in terms of cooling requirements. So being able to reduce the load requirement during the daytime peaks is something that the LED lighting can assist with. So if we look at the time profile, the energy, the load profile throughout the daytime, and see how that marries up with the lighting use profile, will give you an indication of the benefits towards the helping with the load.
Great, thank you so much, Steve. Thanks everybody for posting your responses in the chat. Please continue to do so. It's really great to see all your thoughts. So we've put up our first poll on Mentimeter. What do you believe could be the risk to your country if other countries ban mercury-containing lamps, but your country does not? There has been a link that has been posted in the chat. If you click that link, you will be able to submit your response and we will be able to see it come through as soon as you submit. Otherwise, please go to menti.com and use the code at the top of the screen to submit your response. So yeah, please do that and continue to answer the first question. Yeah, and we will continue with our discussion.
Some comment there in terms of the financial resource constraints and safe disposal of fluorescent bulbs may present challenges. That's correct, and I think Michael will talk a little bit more about that with his presentation later on. But the thing to remember is that our biggest challenge, really, in terms of the safe disposal, is in terms of the lamps that are currently installed that are already out there in our environment. So really what we're trying to do, as sort of mentioned before, is we want to turn off the mercury tap. So the sooner we do that, the sooner we remove this problem of dealing with the safe disposal. So by doing the ban, we're not going to increase or make this sudden increase in mercury waste. All we're doing is, in effect, planning for the years ahead when we are going to have the final disposal of the existing lamps that we've got in our installations today.
Steve, yeah, and this is great. I've seen a few people mention health as well, the health sector being, you know, there obviously being some health benefits. I'm not sure if you can really speak into that, but I'm not sure if it makes such a big impact, but also perhaps something to consider.
Absolutely, I think the health sector is one in terms of particularly with our children and so on. I don't think it's a hugely prevalent thing. It's not my expertise, so I'm not going to make too many comments there. But I think the big issue is that for those that are affected, it is an absolutely devastating health effect. So that is one of the benefits by removing them, is that we're removing that potential exposure to a devastating health impact on people.
Great. I think just out of the interest of time, we might move on to the next poll soon. So Steve, I don't know if you want to just give any comments on what you can see on the poll, and then we'll post the next one and then continue from there.
Yeah, I think people have really picked up some key words there. The absolute key word that jumps out there is dumping. A dumping ground, and this is a real concern. We've seen this even with energy efficient lighting regulations in countries that have already banned, for instance, T12 halophosphor lamps. So the 40mm diameter lamps. Some countries banned those back in the early 2000s. And yet they're still going on ships to those countries, staying at the port, and then moving on to island nations off those countries. So those island nations are really become the dumping ground for factories that are wanting to continue to manufacture, simply so they don't have to shut down those assembly lines. So dumping is a big issue. And then it also does create issues too with the smuggling as another point there for cross borders. It just brings another issue for our customs people to have to deal with and manage if there are neighbouring countries that have not banned fluorescent lamps, and we might have people unscrupulous people trying to move those products across into a country where there is a ban. I think they're great points that people have brought up there.
Great, thank you so much. Okay, we're going to post the second poll. How could your country facilitate or incentivize local LED lamp assembly and manufacture? Once again, the link for posting on this is in the chat, or you can go to menti.com and use the code at the top of the screen. And please remember to continue answering question 1 in the chat room as well. And if you have any questions for our presenters, you are more than welcome to ask them there as well. So I think we're going to wrap this question up in the next 2 minutes or so. So Steve, if you have any final thoughts that you would like to kind of give us based on the answers or the chat room, or based on what you're seeing on the poll, please go for it, and then we can move on to the next question.
Yeah, look, I think there's some again some good suggestions there. The tax subsidies particularly on the importation of LED chips, or the removal of any tariffs, is a good one on those. The investment in the industrial sector is great. Tax breaks, or if you like, accelerated depreciation of new equipment, assembly lines, and so on, is a good incentive for developing the industry and the market in a country. I think the other thing here potentially is also the opportunity for your local industries as well to be producing the other parts. So the diffusers and the plastics, the extrusion or injection molding and so on. There's great opportunities for this to be another opportunity for business in those areas as well. If there's importing of those components, the import costs can be reduced because when you're stacking parts together, you can stack them more tightly into your shipping, so you can get more pieces into a small area, which reduces the cost as well. But yeah, I think there's opportunities for governments to take initiatives here to develop industries, because it's one that is going to be strong. It's quite a good industry in that there's limited hazards associated with it, and it's an industry that can be developed relatively quickly in terms of the skill sets required by the workers. So yeah, thanks, Maxine. I think they're again good comments that are coming in from the audience.
Great, thank you so much. Thanks, Steve. Thanks everybody for your contributions so far. I think we're going to move on to our next presentation. So I'm going to hand back over to Colin, and he will take it from here.
Excellent. Thank you, Maxine. And thank you, Steve, for your presentation. We can go on to the next slide. So as of now, about countries representing about 70% of the global lighting market have taken various policy measures or policy actions to promote a smooth transition to Mercury Free Lighting. But these policy measures have been very different in very different countries, and each country's path has proven to be a bit unique, suited to local circumstances. And so I'll go through a few examples here. One is in Canada. They have a proposed mercury regulation out for public comment to phase out compact fluorescent lamps and linear fluorescent lamps on the basis of mercury. In the US, at the federal level, the US Department of Energy has put out a notice of proposed rulemaking to increase the energy efficiency standards for general service lighting to a level that no non-LED product can meet, and that is not technically possible for a fluorescent product to meet. And so that will, when it is implemented, will phase out all compact fluorescent lamps in the United States. However, in the US, there's I think some legal disagreement about whether the federal government has the mandate to phase out other forms of fluorescent lighting through energy efficiency standards. And so in the meantime, states have been acting to prohibit all forms of fluorescent lighting. And so several states have now adopted laws banning all forms of fluorescent lighting, specifically California, Vermont, Colorado, Hawaii, Rhode Island, and Maine. And in a few other states, similar bills are making it through the political process and are likely to be approved at some point in the coming year or two. What I think is interesting, since there was a question about what economic sectors would benefit, is one of the strongest supporters of these bills has been the waste management companies and unions. It seems these companies in particular understand that they're currently stuck facing managing mercury waste, and they would like to get out of the business of dealing with mercury waste from lighting. And so I think that's certainly a sector that will benefit, and that knows that they will benefit from a phase out of mercury-based lighting. In Latin America and the Caribbean, Brazil is currently revising their efficiency labels for all forms of lighting products. And the government intends to, as part of that process, directly issue a ban on compact fluorescent lamps in order to comply with the Minamata Convention. At the same time, the Brazilian Ministry of Mines and Energy has stated that they intend to set energy efficiency standards that only LEDs could meet. So that would go beyond a simple ban on compact fluorescent lamps, but rather would get rid of all forms of inefficient lighting and move the entire market from street lighting to linear lighting to general service lighting, all to LEDs. Chile has published a resolution that will phase out compact fluorescent lamps by 2024 as well. I think the European Union is a particularly interesting case, as they've already phased out some compact fluorescent lamps and linear fluorescent lamps through eco-design, which is their energy efficiency standards. And then the restriction of hazardous substances will ban the placement of nearly all linear fluorescent lamps and compact fluorescent lamps on the market. I think actually that should be changed from will to has, because I believe that went into effect in the past week. So generally speaking, there's a mix of approaches going on in the European Union, partially through energy efficiency standards and partially through banning mercury-containing lighting directly. And those have also gone into effect in the United Kingdom and Switzerland, even though they're not EU members. They've been following the regulation on hazardous substances. And the UK is also moving ahead with even stricter minimum energy performance standards for lighting products that would represent the world leading level as of now. We'll see if it's the world leading level by the time it's introduced, but it would actually not just phase out all types of non-LED lighting, but it would really promote only the most efficient LED lighting. In Asia Pacific, I'll highlight just 3 countries, though several others are also making similar steps. Bangladesh is developing its first lighting efficiency standards with the express goal of transitioning to all LEDs. The market there has actually already mostly gone to LEDs, and so it's sort of completing that transition. In China, they're developing world-leading LED energy efficiency standards. And I think what's interesting there is the focus is simply developing LED efficiency standards on the sort of assumption that mercury-based lighting will be phased out through the Minamata Convention. And so the regulators haven't wanted to enter into creating a technology neutral standard that would cover all forms of products, when they believe that most likely by the time the new standards would come into effect, only LEDs are allowed anyways. In Pakistan, they simply issued a decree banning compact fluorescent lamps starting from July 1st this year, complying 2 years early with the decision at the COP4 of Minamata Convention. And then we see a lot of movement in Africa, moving on transitioning to mercury-free LED, highly efficient LED lighting. So in the Southern African Development Community and the East African Community, there have been adopted energy efficiency standards across the regions, harmonized standards that will completely transition all of these countries' lighting markets to highly efficient LEDs. And these are technology neutral standards that prescribe a certain efficiency level that currently only LEDs can meet, and that it's not technically possible for fluorescents to meet. Ahead of that implementation of the Southern African Development Community's standards, South Africa has already passed new efficiency standards that will effectively phase out compact fluorescent lamps. And so even before the implementation of the SADC standard, South Africa has gone ahead and begun the implementation of a standard that gets rid of compact fluorescent lamps. And then finally in Nigeria, the Technical Committee on Electrical Standards has approved lighting efficiency standards that also could only be met by LEDs. And it's expected that this standard will be signed off completely in the coming months, and will be enforced presumably in the next year. And currently, other ECOWAS countries are considering aligning with these standards and seeing about developing a similar regional standard that would be along the same lines as what's been approved in Nigeria and what's been adopted in the Southern African Development Community and the East African Community. So you can see there's a wide range of ways to go about phasing out toxic lighting, whether through direct bans, through regulations on hazardous substances, or through energy performance standards. And it really depends on whether it makes most sense in the local context to focus on directly banning the hazardous substance or going through the energy regulations route, as both benefits exist and both would provide a justification for making the transition. And so I think with that, we can go on to the next slide with the question. And so it would be great to understand from everyone what policy implements such as efficiency standards, bans, or even incentives would be most appropriate for shifting the lighting market away from mercury-containing products in your country.
Great, thank you so much, Colin. That was great. So we are posting this question in the chat. And just as with the first question, please feel free to post your answers in the chat. And if you have any questions for Colin, feel free to post them there as well. We would love to hear your thoughts. If anyone has just joined us, we are in the chat room discussing the question that is on the screen. Please introduce yourself in the chat as well with your name, the organization you represent, and the country you are from. It would be great if you could also include your country in your response to this question so that we have context of where you are coming from.
So I'm seeing a few answers. I think it's definitely a good answer to say that some combination and maybe in a phased approach can be most appropriate. Whether it's swiftly and easily implementing a ban, then pairing it with efficiency standards, and ultimately including incentives. Or it doesn't necessarily have to be that order, but some combination can actually be very effective as well. I think also some comments about the challenges of implementing. Definitely there can be challenges implementing bans or implementing energy efficiency standards, whether it has to do with working with customs to make sure that they enforce it, addressing issues with generally porous borders, ensuring that there's the capability to test products and verify that they are indeed what they claim to be. So there are indeed a lot of challenges with enforcing, but they're not insurmountable challenges. And we've definitely seen a wide variety of countries successfully enforce bans or efficiency standards. Yeah, I see a very good point that there should be a study of the impact of the measures taken before the regulations are drawn up, and I think that that's definitely an important part of most standards development processes, developing a regulatory impact assessment. In some cases where, such as with the regulations in the African continent, they're already harmonizing with levels that have been implemented in other areas of the continent. And so I think it's easy to see what the impacts would be from implementing those regulations. For example, the regulation, the energy efficiency standards phasing out fluorescents have already been adopted and implemented in Kenya. And so we can look at Kenya as an example of what happens. And it seems so far that the impacts have been positive and as expected. I also see a comment that a global ban would be important to help protect unregulated markets, and that's an important point. Also, when it comes to enforcement, while there are ways to make sure that these regulations are effectively enforced, having a global ban gives much more certainty that it will be properly enforced, because you don't have to worry anymore about products coming in so easily across the border. These have been banned also in the manufacturing countries if there's a global ban. And then, frankly, they're just not being made anymore, or they would not be made anymore if there was a global ban.
Great. So we've just posted our first poll. And so we would love some responses here. Have you observed a shift from fluorescent to LED lighting in your local markets? Once again, the link has been posted in the chat for you to vote. Otherwise, you can go to menti.com and use the code on the screen to vote on the poll. We would love to hear your responses, and please continue to answer the question in the chat room as well.
Seems everyone responding has indeed seen a shift from fluorescent to LED lighting in their local markets. And I think, certainly this has been observable, where I am as well, and in most countries where we've been studying what's going on in the lighting market. I do see the note saying that the shift hasn't, not entirely as an answer, and I think that's also relevant. I think very few countries have fully phased out the fluorescent lamps, other than the ones just mentioned on the last slide, and so these do remain in the market, and the shift is not complete most places. think it's also interesting to note that the shift, some people are noting that the shift has been not due to toxicity, but rather due to efficiency in lighting. And I think relatively few people are, or many people are unaware of the toxicity in fluorescent lamps. Whereas the energy efficiency benefits are far more immediate and apparent. If you're paying your monthly light bill, you'll notice a change if you change all of your lights to LEDs.
Great. I think we have some good answers in that first poll. So let's head on to the next one. What more could be done in your country to accelerate the transition to mercury-free lighting? And once again, the link is in the chat to vote, or go to menti.com and enter in the code on the screen. We'll give this a few minutes and then we'll wrap up the question and move on to the next presentation.
So definitely, I think the first answer will work. Ban and enforce the ban on mercury-based lighting. That certainly would accelerate a transition. I think incentive policy also is a good tool for accelerating the transition. And awareness raising. As mentioned before, many people are not aware of the mercury in fluorescent lamps. And so just making sure people are aware of that. And also increasing the awareness of LED benefits and the efficiency of benefits for LEDs. Yeah, definitely. I'm seeing a nice mix of, the same bans, enforcement, subsidies, and of course, awareness raising. And I think that all makes quite a lot of sense.
Great, thanks, Colin. I think we're going to wrap up here. If you have any final thoughts, then feel free to just, give us your thoughts and then we can move on to the next presentation.
Sure. So I'm, first of all, I just want to say thank you for the opportunity to speak with everyone here and to have this chat. And I think definitely I totally agree that a combination of bans, efficiency standards, incentives, and awareness raising will be important to ensure this transition to mercury-free lighting, and to make sure that every country manages to realize those benefits. I think it'll be important to ensure a global ban on mercury-based lighting. So once again, thank you everyone for this opportunity to speak with you, and I'll hand it over now.
Great. Thank you so much, Colin. That's great. So we will head over to our final presentation, and so I'll hand over to Michael.
Thanks very much, Maxine. Today I'm going to talk a little bit about the challenges to managing spent or discarded mercury added lamps. And but just by way of just starting out, next slide, please. My background in the 1990s, in addition to what I mentioned earlier, working with state and local governments, I also worked with the mercury added lamp recycling industry in the US. And so I'm very aware of the many challenges of collecting, transporting, processing, and disposing of mercury added lamps. And even before we get to the stage of disposal, it's important to recognize, and others on the call have mentioned the fact that that there's mercury in these products, and most people aren't aware of that or the exposure risks. And even before that lamp was produced, it was creating mercury pollution from mining, from recycling, from storage and transportation by brokers and traders, and then the manufacturers inserting mercury into the products. And along the way, many workers getting exposed. And we really shouldn't lose sight of that, because in the research, there's a strong indication that mercury recyclers are often very, very highly exposed without them knowing it, or any personal protective gear. So as was also stated, that turning off the mercury tap, if you will, is the best way to avoid disposal in the future. But what we're here to talk about today is this hazardous waste lamp management and disposal challenges now. And one of the observations I made at a recent presentation is that there really isn't a very high percentage of collection for recycling of mercury added lights. In fact, it's estimated that there's only 20% recovery in OECD countries, 5% in developing countries, and non-existent rates in the least developed countries. So if you're struggling with what to do with your spent mercury added lighting, first of all, I wanted to assure you, you are not alone. This is a worldwide phenomena, and except for in the few locations where there's been some kind of an advanced disposal fee, like in the European Union with the WEEE directive, or where you've had some mandates for EPR or extended producer responsibility, the financing really isn't there. And why I want to emphasize that at the start is that this is a very pricey waste management category. And in order to be able to have any kind of sustainable approach to lamp management, then you really need to have some kind of advanced disposal fee or extended producer responsibility agreement when the lamps are being sold, because that's your revenue source. And as time goes on, what we're now looking at is very huge, significant global quantities of these lamps that don't have a funding source for management. And so most all of my presentation is premised on the challenge of financing. And I don't want to not put that up front, because this is not like managing solid waste. This is a hazardous material, and based on the countries that have had lamp processing facilities, there is a number of permitting requirements and also safety standards, as I mentioned earlier. So getting to the first slide, as is probably fairly obvious. I'm sorry, could you go back to the first slide? Sorry about that. So there are many lamp breakage release pathways, and these include the fact that lamps are like eggshells and they break so easily. the recycling lamps incur high cost compared to the value of the product. And in some cases, or many cases, depending on what this recycling scheme is, it costs as much to recycle and properly manage and disposal of a mercury added lamp as it does to purchase one. So this low or negative value of recovered materials from lamp waste, which, as I keep emphasizing, is often hazardous, they're very costly to manage. And that when you look at the permitting, siting, constructing, lamp processing, it could take a number of years. And what I didn't mention, but overriding again, is the financing. Where does the financing come for these expensive lamp processing facilities, not to mention the infrastructure, the transportation, the collection, the workers to make this happen? And then meanwhile, as we're seeing in the earlier presentation, significant reduction in the sale of mercury added lamps mean for those countries where there is an advanced disposal fee or some kind of a EPR program, that there's less and less revenue resulting in how to finance these kind of expensive lamp recycling. But there is a low tech option I'll be talking about, so there are some avenues. So next slide, please. So when we get into talking about the challenges of environmentally sound management and disposal with or without hazardous waste infrastructure, this is an important point, no matter what category of mercury added product discard that you're talking about. In developed countries, in many cases, there's already a hazardous waste infrastructure in place. There's disposal facilities, there's permitted hazardous waste transportation and permitted transfer stations and collection points, interim storage, et cetera, et cetera. So even in developed countries, it's been very challenging to set up and to get financing for these lamp recycling schemes. So when we're talking about the main options, and this will tie into one of my questions coming up, one is to continue to dispose of the lamps locally the way they currently are. The second is to bear the high lamp processing recycling costs, and or depending on whether you have a hazardous waste disposal facility for the mercury, if you don't have a way to recycle the mercury into something new, that gets very expensive. The cost of exporting adds to that. And then the third option is this low tech option I was mentioning earlier, to utilize drum top crushers, which I just want to emphasize here. This is not really recycling comparative to the high tech lamp recycling processing facilities. This is a very low tech, mainly for linear to volume reduction, still resulting with hazardous waste challenges, but perhaps manageable. And as I was indicating earlier, many developing countries lack many aspects of the hazardous waste infrastructure to be able to build off from to make these kind of collection, managing, disposing schemes somewhat cost effective for environmentally sound management and disposal. And all these come together when you're looking at a potential recycler, a business person coming into your community, into your country, that results in even higher hazardous waste management costs along the way. And further, where environmentally sound management and disposal of mercury lamps are not available, some are suggesting storing. And I would really discourage, unless obviously you are in the middle of a UN finance project or something like that, but I will encourage people not to consider collecting and storing lamps unless they have an environmentally sound management and disposal solution financed and figured out, because we don't want to see future contaminated sites being created. Next slide, please. So I was talking about the expense here in the US where I'm from. We did a cost comparison of recycling mercury in a compact fluorescent lamp compared to collecting one thermostat. And a thermostat has about 4 grams of mercury. Compact fluorescent light has maybe 5 milligrams of mercury. So, and there's also the example here of a thermometer. A thermometer contains maybe 100 times as much as a CFL. So our U.S. Environmental Protection Agency estimates the recycling cost for a CFL about $0.50 US. And in the U.S., we have it's a manufacturer created thermostat recycling corporation that charges $25 US recycling fee per container of 100 thermostats, which comes out to be a cost of about $0.25 US to collect 4 grams of mercury versus, the challenge of first of all, gathering 400 to 500 compact fluorescent lights into one place and to collect those. And the bottom line is it's 1,600 times more expensive to recycle mercury in a compact fluorescent light compared to a thermostat. We also, and I didn't have enough time to insert another slide, but we have another slide which lists the Minamata Convention Article 4 ban mercury added products, and it shows the relative amount of mercury in each of those products. And there's a great need, and I really want to emphasize, for some prioritization when we're talking about managing environmentally sound management and disposal of mercury added products, because we all know we have limited resources, limited staffing, limited capacity. And so the question is how to invest that limited resources into finding the solution for the mercury added product discard category, and whether lamps certainly would not be on the top of my list. It would probably be further down near the bottom of the list. So it's time for the first question, if that could be posted now, Maxine.
Perfect. Thank you so much, Michael. That's great. So yes, here's our final question for today. What are the main challenges of environmentally sound management and disposal of mercury added lamps? If you could please post your responses in the chat. We have posted the question there, and we will shortly post a poll. So yeah, please continue to post your responses and any questions you have for Michael as well.
Right, I see here, first of all, taking advantage of encapsulating mercury in mines, which is certainly something that has been studied, particularly in Germany, and it is a potential avenue for we're looking at getting a little bit creative with what to do. There are, like every other mercury added product category, a mercury source that when it gets into the environment, it's a persistent bioaccumulative toxin, accumulates in the water sediment, and enters into the food chain. We're well aware, and that's part of the challenge. Yeah, and this question about the lack of capacity certainly is ties in with the public not really knowing, first of all, that there's mercury in these products, and lack of awareness, lack of collection programs. One of the things that we would discourage in this question having to do with incineration is that would be our last choice, because then the mercury would vaporize into the air much more quickly. When you landfill mercury, it slowly migrates. It doesn't emit as quickly, especially for those incinerators that don't have mercury controls on them. So yeah, there's a challenge, as I mentioned earlier, about lack of temporary storage facilities to start to even be able to collect and manage mercury added products. Totally lack of appropriate technology. The technology is out there, and for some the larger office buildings, government buildings, there have been programs that have been set up to be able to, almost with like a reverse distribution system, when you pull out the linear mercury added fluorescent tubes, they go back in the truck where the LEDs come in, and if there is a recycling or processing center, that's probably one of your more cost-effective areas for managing that. Maxine, I didn't know if there was another question or another opportunity. I did have one more slide here, but I don't want to get in front of your process, so go ahead.
Great, thanks, Michael. Yeah, so we've posted this first poll. If everyone can respond to this poll using Mentimeter, going to menti.com and using the code, or using the link in the chat. We are almost at the end of our discussion time, so we're going to move on to the next poll shortly, and then we can wrap up from there. But Michael, I know you have a slide, but if you want to just kind of, you can even just talk us through now what you would like to say from that while people respond.
Yeah, I definitely would, because I see the one response that there's no options, and in fact, the last slide speaks to an option, and I'm sorry if I mixed up the order of my presentations here, but there is a volume reduction, low-tech volume reduction approach called drum top crushers, primarily for linear tubes, which fit on the top of a 55-gallon drum. They're used primarily to reduce the volume of lamps, improve the storage and handling, and reduce shipping and hazardous waste disposal costs. So it's a process where you can crush the lamps where the material gets consolidated in a 55-gallon drum. It's got a filter on the top that needs to be managed as a hazardous waste. And just due to the low-tech technology, when you pull the lid off the drum top crusher, there's a significant release of mercury at that time. Once you cap the lid on that material can either be sent to a hazardous waste disposal facility if you have that opportunity, that availability, and also the filter on the top should be treated as a hazardous waste. So there's a significant release of mercury. It doesn't capture as much as a high-tech recycling facility. And I just want to again really emphasize that these units should pay particular attention if you're going to have these operational. And I know a number of these units are operational, particularly in developing countries, also developed countries, that you need to really ensure personal protective equipment, regular worker testing. And in warmer climates, you might want to consider operating these drum top crushers outside to reduce worker exposure. And that was my summary on that last slide. So
Great, thank you. So yeah, as you can see, we've posted a poll asking about these drum top crushers that Michael was just talking about. And I think the slide is included in this presentation, which will be distributed after this discussion. So you'll be able to see Michael's slide about the drum top crushers and how they work. So yeah, here's the poll. So please respond to this and continue responding to the question in the chat. And remember, if there's any questions for Michael, please feel free to post them in the chat. Yeah, Michael, I know there was one question that kind of came in through the Q&A section. I'm just going to find it. I think it was more about disposing of CFLs locally. How do we do that? Is it incineration, or if there's an example about that?
right, and I mentioned earlier that would be my last choice, would be incineration, because then that mercury is going to instantaneously vaporize. It would perhaps less emitting source, but obviously the mercury is going to be emitted over time, would be to landfill it. Unfortunately, I'm sorry. I'm again sorry to say that we don't have a lot of good options. Actually, we don't have very many. There really needed to be some kind of advanced disposal fee up front when these products were purchased in order for them to sustainably be recycled. That's what we've seen in the European Union. Other places where there are larger generators, they usually where in developed countries where there are these larger generators, office buildings, that they are charged, they are responsible for the financial cost of recycling, which is what makes recycling work in many developed countries, and also in developing country is the large scale collection and recycling of the 4-foot or the 8-foot linear tubes. Those pretty much help to cover the cost. But finally, I would go back to what the two earlier presenters were saying, is that in the long run, the best thing we can do is turn off the mercury tap as soon as possible to stop creating more mercury waste into the future. And that's just not for fluorescent lighting, it's for all the products listed in Minamata Convention Article 4, as well as, I want to overemphasize the importance of managing elemental mercury. Wherever you have elemental mercury, that is probably your most cost-effective category to manage. Thanks.
Great. Thank you so much, Michael. That was phenomenal. Thank you. So I think this is probably a good time for us to start wrapping up. I think there's been some really good discussions had here today and some good suggestions and way forward. And I always think it's really nice to see in the chat the different things that people are experiencing in their countries, the challenges, and just hearing from some experts ways that we can overcome these things. So I'm really glad that we've had you all here today. So thank you so much to everyone for attending today's discussion. There is an evaluation poll that should have popped up on your screen. Please, will you answer these questions for us? We really appreciate hearing your feedback on our discussions. And then I would like to say thank you to all of our presenters, Michael, Colin, and Steve. Thank you so much for giving us your time. I know time zones is always a challenge. Steve is in Australia, so it's very late at night for him. So thank you so much for being here and making time for this. And thank you to all of our participants for coming today. We appreciate having you in our discussions and value hearing your input in the chat room. Thank you to Eunice, who has been in the background working hard, making sure all of this comes together and that this discussion is possible. And so just a big thank you to her. And yeah, we really look forward to having you at our future discussions. Our next discussion will be on the 10th of October, and it will be on risk communication. So please keep an eye out for a link to register for that discussion. If you have not signed up to be a member of our chemicals network, please will you consider doing that? A link will be posted in the chat for you to sign up. This is where we send out all our communications about our upcoming discussions, and we send out resources and yeah, just keep you in the loop about all the discussions that we have coming up. So please consider signing up to be a member of the Chemicals Network. Following this discussion, we will be sending out a digest, which will summarize this discussion, as well as the PowerPoint presentation, and we will post the recording of the discussion as well somewhere for everyone to have a look. So once again, thank you so much. Thank you to our presenters. We really appreciate your expertise and just helping us make this discussion a possibility, and to the whole team that really worked to pull this together. We appreciate all of you. We wish you a wonderful rest of your day, whether you are just starting or ending it. And yeah, we look forward to seeing you at the next discussion. Thank you so much.